In this video, we're going to talk about fractions. A lot of people are terrified of fractions. Pretty much it doesn't matter what age you are, you're not alone in this fear. In this video, I plan to explain each step like I'm teaching you how to ride a bike for the first time. Once you actually learn how to ride a bike, you probably think to yourself, man, that was so easy. How could I possibly not know how to ride a bike beforehand? That's my goal. I want you to say that about fractions. So starting out, we're going to take really small steps. We're going to talk about the multiplicative identity. The multiplicative identity states anything times 1 is equal to that anything. Now, if the letters are creeping you out, I want you to just throw out any random number. Let's say 5. 5 times 1 is 5. You can pick a big scary number, maybe 1,000 times 1 is still 1,000. You can pick any rational number that you can think of, times it by 1, and you'll get that same rational number. That's what the multiplicative identity states. The next thing that we want to talk about is 1. 1 can look scary sometimes, and we don't realize it is 1. So I want us to take a look at, for example, 3 divided by 3. Now, hopefully, 3 divided by 3 is something where you're already shouting at the screen at me and going, 1 crazy lady, of course. How is this going to help me with fractions? Well, we're going to have different looking 1s involved with fractions, and you'll see 3 divided by 3 here is a fraction in itself. It's just division problems are fractions. And 3 divided by 3 is 1. Now, we might not have nice small numbers that we're working with. Our goal is to start with nice numbers so that we feel comfortable, we grow to become confident, and then we'll make the numbers look scarier. So even if you had 1,000 divided by 1,000, you'd be like, oh, the same thing divided by the same thing is 1. So any number divided by the same exact number is 1. This is a very important concept, and we want to make sure we feel comfortable with this. These two ideas are the most important part that we really want to think this is the nicest they could possibly be to us. And if you don't feel comfortable with these, I want you to go back and review these concepts, maybe sit down and just make up some numbers and go, yeah, I really do believe this. I feel comfortable with it. Okay? Even if you're working with negative numbers, you could say I have -3 divided by the same thing. -3 is equal to +1. So make sure that we understand the same thing, anything that is not 0, divided by that same thing is equal to 1. And you might have heard me sound like, one of those greasy car sales kind of deals where they're like, oh, a little bit mumbled under a voice there. I said, as long as it's not 0. That is important. Whatever number we're working with here, this rule only applies if we're not dividing by 0. We can't divide by 0 in this fractions, what we're working with right now. All right, now, we do have to get some vocab out of the way because in order to work with fractions, mathematicians are going to try to trip you up with the different vocab words that we have. So we have those two rules. Anything times 1 is still that same thing, and anything divided by exactly the same thing is equal to 1. We want to make sure we feel comfortable with those two ideas. And then we're going to talk about our first vocab word, which is numerator. Now, numerator is the fancy talk for saying what's in the top part of our fraction. And now on the bottom, we have denominator. Bear with me, I'm not a good speller, so I was sounding that out as I wrote it. So, numerator divided by denominator. You'll often see capital N and capital D often used for this notation. You can also see this where we talk about these words in terms of division, in which we have a dividend is the numerator. I'll write out the word dividend. And then we have the divisor, and that's the denominator. These words mean the same idea, just in different contexts. This numerator, denominator is reserved for fractions. This is worked for division. We want to make sure that doesn't matter what word somebody uses when they speak to us, and that somebody could be directions in a worksheet or a test. We want to be comfortable with them and that they mean the same idea. There are two more words that we got to make sure we feel comfortable with before we really can get into talking about fractions. These vocab words are something that I'll tell my students you need to memorize. It is very important. If you're going, whoa, lady, you went really quick here, I recommend that you write these down, maybe do a quick Google search or go to like purplemath.com and get their definitions and really sit on them for a bit and make sure you feel comfortable with these vocab words. My shortened version of what they mean is numerator is in the top of the fraction, dividends the top part of the fraction, denominator is the bottom, divisor is the bottom. And if you want to see it this way, you have the denominator divides into the numerator when we talk about it in long division terms, okay? So make sure you feel comfortable with those words. Now, the next two words that we're going to need to make sure that we feel comfortable with is factor and multiple. Factor is definitely a tricky word for a lot of students. In mathematics, it is a number or algebraic expression that divides another number or expression evenly. That is a lot of words, so I'm going to explain factor through example, okay? So let's say we have a number 12, that's a 12, and we divide it by 3. 3 times 4 is 12, and we have no remainder. So 3 is a factor of 12. And let me write that out. 3 is a factor of 12. That means I can take 3 times some integer and get 12. That's why it's called a factor. Factors are like pieces of a puzzle that when you group them all together, you can get a larger number. So other factors of 12, like if we wanted to list out factors of 12, we could say that we have 1, because 1 divides into 12 evenly. If I were to write out the long division, 1 times 12 is in fact 12, and I have no remainder. You might see some people will use a definition where they say there is no remainder. That's what it means to divide in evenly, okay? So 1 is a factor of 12. 2, because 2 divides into 12 6 times evenly, no remainder. 3, we just discovered it. 4, obviously, because 3 is 1. 3 times 4 gets us it. And then 6, and last but not least, 12. These are actually all the factors of 12. Sometimes listing out all factors can take a lot longer for the larger numbers. But you do want to feel kind of comfortable where you go, oh, I can think of some of the factors. That will aid us in our fraction work, okay? Now, I said there was 2 words, factor, and then the other word is multiples. Before I go to multiples, I'm just going to state one more time the definition for factor. Factor in mathematics is a number that divides another number evenly with no remainder. That's our key, okay? Now, multiple. Multiple is a number that can be divided by another number without a remainder. You're going, oh, lady, didn't you say the same crazy thing? Let me give you some examples, and then I'm going to read that again, and you're always welcome to go back in the video and re-watch it, and I'll say it again later, okay? So, multiple. Let's talk about multiples of 3. I'm going to say another definition of multiple. It's kind of good and bad in mathematics that we have different definitions that say the same thing. In that way, you can always search words that a mathematician uses on you, the book uses on you, whatever system you're working in, and you can come up with a bunch of different definitions that all mean the same thing, but one of them speaks to you, and you're like, yes, I understand that one. So multiples of 3. That would be 3 times a whole number. 3 times 1 could be a multiple. 3 times 2. 3 times 3. 3 times 4. 3 times 5. Hopefully you're getting my pattern here. 3 times 6, and you could go on forever. There are infinite numbers of multiples out there for as long as you're willing to multiply that number. And you see here, look, 3 is a multiple of 12, but it's a factor of 12, right? It's a little bit very similar. You can see the numbers appear in there. So a multiple in math are the numbers you get when you multiply a certain number by an integer, okay? So let's do it one more time. Let's talk about multiples of 6. So multiples of 6. We could have 6 times 1, 6 times 2, 6 times 3, 6 times 4. What did I write 6 times 3? I wrote 13. What a crazy woman. I'm sorry, 6 times 3 is 18. 6 times 4, and you keep on going on forever and ever. And then just double check yourself, because even if you have a master's in math, you still could write something completely nutso down, even though you know what it should be. That was one of my biggest mistakes in school. I would always write things down wrong. So give yourself that always good double check. So multiples of 6, we can list them out. And then sometimes you might find in fractions, you find a common multiple. And even just between 3 and 6, you might see, well, there's 6 is a common multiple. 12 is a common multiple. 18 would be a common multiple. Actually, almost all the multiples of 6 are multiples of 3, because 6 is 2 times 3. So we have our definition for multiples, a number that can be divided by another number without a remainder. Or we can say a multiple in math are the numbers you get when you multiply a certain number by an integer. These last two definitions, you should probably be going like, oh, this is alarmingly close, but they are not the same. All right? 12 is a multiple of 3. 3 and 6 are factors of 12. So let that soak for a bit. Think about that. There are a few things I tell my students to memorize, and this is one of them, where I want you to really focus on memorizing these definitions and feel comfortable. Now you're probably going, that's great and all, but I still haven't seen any fractions. Now let's go into fractions, because we feel comfortable with the vocab. We have to understand the language before we can go on to examples. So I'm going to give us a vague direction in which it says simplify. Simplify is a direction reserved for expressions. And my first expression that I'm going to see here, because we work in base 10, I'm going to go ahead and use 5 over 10. Now, the direction simplify is one of the meanest directions in my point of view, because it just leaves you to figure out what the mathematician wants you to do, right? A better direction here, what simplify really means, is we want to remove a factor of 1. And not just any factor. We want to simplify it. We want to remove the largest factor of 1 in this problem. So, a lot of you probably feel comfortable with 5 divided by 10, thinking about that as a smaller fraction. I'm going to go really slow here to the point where you might be yelling and going, let me speed up this video or find another one. That's fine, that's fine. We are going to look at the factors of 5. And I intentionally picked 5 because that is a prime number. 5 only has itself and 1. Now this is a hint to help us out with 10. 10, also a very nice number that I picked. The only factors we could probably come up with here are 5 times 2. Or we could have 10 times 1, right? There's another set of factors there. Why I went with 5 times 2 is because I want to remove a factor of 1. And if you go back to all those little definitions, I'm trying to be sneaky here and find the factor that both of these numbers have in common. So I'm going to remove it, because 5 divided by 5 is really 1. All right? But I'm still left with, don't forget about this 1 up top here and that 2. And I have 1 times anything is still the same thing. So 5/10 can reduce, it can simplify. I can remove a factor of 1 to bring me down to 1/2. So that is how we are going to remove a factor of 1. I personally think removing a factor of 1 is the nicest directions because it really gets us like what you're supposed to be doing. All right, now you're probably going, duh, I got this. Removing that sort of small numbers, I can handle it. Usually, students are fine with very familiar numbers. What we begin to struggle with, let's do another example, is when the numbers start to get a little bit larger or the problem is displayed in a different way. Actually, I'm just going to change our directions. Let's say my directions say fill in the blank. And that's like even worse because I have no idea. They're not giving me any hints here, okay? So our first problem that we're going to see is we have 3/4 is equal to blank over 8. Now, they use the equal sign here, so we know these are equivalent fractions. That means this fraction, whatever I put up in the numerator, should reduce and simplify to get me this fraction. Now, we're going to kind of work backwards through this, where I'm looking at 3/4, and I want to magically multiply it by 1 so that 8 is in the denominator. But I have to pick this 1. This 1 I'm going to pick is special in the sense that it is a number where it is the same thing divided by the same thing. So I'm going to make 1 be a fraction. And I go, what times 4 gets me 8? And you'd probably be shouting at your screen going, 2, lady, I got it. I know how to multiply by 2. Okay, calm down, calm down. So I got the 2 there. And when we multiply fractions, we multiply just straight across. It's like the most beautiful thing. It's commutative law in fractions. When we're multiplying, order doesn't matter. And we go straight across. Numerator times numerator, denominator times denominator. So we have 3 times 2 gets us 6. 4 times 2 gets us 8. So filling in the blank here, our answer would be 6. Let's do that one more time because that's a little bit funky. Because as we get used to making our fractions bigger, it'll be a little bit nicer. I'm not going to say easier necessarily, but we'll feel more comfortable going backwards when we have to simplify fractions. So let's say we have 11/2 here. And we know this is equivalent to 33 over blank. So we're going to fill in the blank again. It's the same exercise. I am going to multiply this number times 1. Now, 1 times anything is the same thing, so that's why it is still equal. But I am going to choose the 1 to be some number divided by exactly the same thing. Now, how am I going to pick this? It could be any number you want to pick. You could pick 4 for all you care. Maybe we don't really want to do this, but we could, right? 11 times 4 is 44. 2 times 4 is 8. And now you're looking at this and going, no, crazy lady, I wanted 33 in the numerator. Well, that's fine. I just picked the wrong 1. I can multiply by any type of 1, and it's going to get an equivalent fraction. Equivalent is the fancy word for saying it's going to be equal. Now, 4 is not the number I want here, right? So let me erase that. We want 33, so now I have to think, well, what times 11 could get me 33? And sure enough, 3 times 11 is 33. If I multiply by 3 up top, I got to do the same to the bottom. You might hear some people say that phrase. What I do to the numerator, I must do the same to the denominator. It's the same idea. Really what they're expressing is the multiplicative identity, where you're multiplying by 1. And the 3 divided by 3 is 1. 1 times anything is the same thing. So now we're going to multiply our denominators together, and 2 times 3 is 6. So sure enough, the blank that we need to fill in here is 6. Alrighty. So with that in mind, let's do another one with a little bit harder numbers. And the harder numbers really appear when you start seeing primes, okay? So let's say we have 39 over 12. And we want to know what this could be, 13 over something. So here, we're kind of going the other route, where we are reducing our fraction. We went from a larger number up top in the numerator to a smaller number. And if you didn't notice, scoot back to our first problem. we went from 4 to 8. It got bigger, so it was very nice in the multiplication. Same deal here. We went from 11 to 33. We got bigger. Now we are going from bigger to smaller. Some students like to write this a little bit differently. I'm going to show it two ways. All right. I'm going to start with this completed number, and I am going to say what factor is the same in this numerator that's also in the denominator. And remember what factor is. Some piece that can multiply together to get 39. And hopefully when you look at this, you're like, ew, 39. You can use some divisibility tricks to help you out here. 3 goes into this number, however you see fit. So when I look at this, I see 3 times 13. And this is definitely one of those numbers where you probably feel a little icky unless you're familiar with those primes, because 13's prime and 3's prime. So it's just a little gross. And the same idea for down here in the bottom, 12 is 3 times 4. Of course, there's 2 times 6 as well, 1 times 12. There's a whole lot of options here. But the reason why I picked 3 times 4 is because they both have that same factor. And I'm going to remove that factor of 1 because 3 divided by 3 is really 1. It's gone. And I'm left with 1 times 13 over 4, which is still 13/4. And I got that numerator I wanted, so the blank is 4. If you don't like seeing it this way, that is totally normal. I think a lot of students prefer to think about it where they divide in this fraction. So let me show you it this way, where they say, what's the common factor between 39 and 12? And now you have to know how to find your factors, which we gave the definition. That's working with your multiplication tables. The better you are at your multiplication tables, the easier it is to find factors. And 39, you would find, oh, it has 13 and 3. Those are the only factors that are really useful here because 1's not interesting. So I'm going to divide the top by 3. And whatever I do to the top, I must do the same to the bottom. And that's coming from that identity law of multiplication, okay? So I'm going to divide by 3 in the bottom, right? So once I've done that, 39 divided by 3 is 13. 12 divided by 3 is 4. We get the same answer. Now, I'm not writing this in red because it's wrong. I just, in my biased opinion, don't like seeing this division sign. I see it this way. But, you know, that's what makes the world great. Everybody's brains think a little bit differently. And if this way's not jiving with you, there's so many other resources out there to find one that does work, okay? So that is how we are going to reduce our fractions. We could do it that way. We can also see this with whole numbers, okay? So real quick, we're going to fill in the blank, and we have 3 is equal to 12 over blank. And we got to fill in this blank space here. And now this might be really gross to you because you're like, what? I don't have a fraction here. I get it, whatever I do to the top, I got to do the same to the bottom, but there's nothing in the bottom. Not true. There is something in the bottom. Remember when I mumbled on my breath about that A can't equal 0 business? There is never 0 in the bottom, okay? We always have our nice whole numbers divided by 1. It is implied because anything divided by 1 is still the same thing. Very similar to our rule of anything times 1 equals that same thing, right? Anything divided by 1 equals that same thing. These are handy properties to keep in mind, okay? And that's because 1 times anything is the same thing, and commutative law is working out here too. It's very powerful. Now, as soon as you see a whole number and you are working with fractions of any sort, do yourself a favor to visualize the first maybe 100 times you work through these problems and just toss a fraction, even if you don't necessarily need it. Just do it for good exercise so your brain visualizes it's really divided by 1. So now when we see 3 divided by 1, we're going, oh, that's still just 3. I want my numerator to get bigger, so it's kind of a little bit easier. I'm going to multiply it by a factor of 1. And the one that I'm going to choose is what times 3 gets me 12. And 3 times 4 gets us 12. But if I do anything to the numerator, I must do the same thing to the denominator. And that's where I'm getting 3 times 4 is 12. 1 times 4 is still 4. And if you reduce this, remember how we talked about fractions and division being, basically the same thing. 12 divided by 4. 12 is my numerator, or the dividend. In this case, he's the dividend. 4, the denominator, is my divisor, can go into that evenly 3 times, and I have no remainder. So now we have the answer to fill in our blank, and it's 4 here. All right, I'm going to stop there. If you have more questions, feel free to comment, and I'd be happy to answer them. Thank you.